25, we're looking at this diagram and trying to figure out what x must be that would make point N the incenter. You see, we don't have enough information right now to declare N as the incenter, but assuming it is, what would x be? Because then whatever we find for x, that would make it the incenter. It's kind of working backwards. So you're going to take a look at the diagram and think about anything that you know about an incenter. Again, that incenter is formed because the red lines are angle bisectors. Okay, so you could mark those the same if you want. You could mark those the same. You could mark those the same. Okay, then the other thing that we know about the incenter is that it's the same distance away to the outside edges of the triangle. Okay, so if this is truly the incenter, that would mean that this line segment, the little blue guy, is the same as that one and that one. Okay, so we pretty much have marked everything that we know about the diagram. Now it's a matter of figuring out how we can use the information given to us to find the value for x. Well, the value for x is, we've got 14x here, just this little line segment. You can use what you know not only about incenters, but about right triangles, because inside the larger triangle, you've got a whole bunch of right triangles. I don't really have enough information about this right triangle, but I do about this bottom one down here. This right triangle over here, I've got two of the sides already. I know that my hypotenuse is 25, and I know that the long leg is 24. The only thing I'm missing is this line segment and h. Well, I can use Pythagorean theorem. I've already done that for you. If you use Pythagorean theorem and say a squared plus b squared equals c squared, you can plug in 25 as your hypotenuse, plug in your leg, and then you're trying to solve for the short leg. When you do that, 24 squared ends up being 576, 25 squared ends up being 625. Move that to the other side, so a squared must be 49, and if I take the square root of both, I've got a as 7. You might have even remembered that as a Pythagorean triple, 7 and 24 and 25. So you could skip all of this if you just remembered that that had to have been the side length. But now I know that this side length is 7. And you might not recognize right away that you might think that doesn't matter because I'm looking for this up here. But remember, all three of these little blue lines are the same. So if this is 7, this distance that we're looking for has to be 7 as well. The only difference is it's marked as 14x. So you could say 14x has to be 7. We just found it to be equal to 7. So now you've got an algebraic equation. You can divide both sides by 14. That'll cancel these out. X must be 7/14 or 1/2. So if I make x 1/2, that makes this 7, and that makes this 7, and it satisfies everything that I need to say that all these are, the red lines are angle bisectors, which means that this then would be the incenter.